So number 5, asks you to take the y equals x squared graph, and you're going to construct your coordinate axes according to some instructions. And y is the depth of water, cylindrical container, centimeters, and all that. So I'm going to actually use the x squared function. But don't expect necessarily a problem about water in the cylindrical container. I can have any function with any appropriate interpretation, right? So what you want to look at is how to interpret the values and the rises and the runs and the slopes, okay? So we start with a graph of y equals x squared, but we don't put any axes on it, okay? Now, if you want to draw real light axes and do it, okay, but don't believe the axes because we're going to put other axes on it. So the graph is going to kind of have this shape. If you think you can draw a good parabola, that's okay. Even if your parabola is not so good like that one. I always tend to be lopsided to the right, okay? It's anti-symmetric, a little too far on the right. Got something to do with the way my brain is wired. They haven't institutionalized me for it yet, but maybe. Okay. Now we put the axis on it. So what's it say to do? Okay, a y-axis passes through the leftmost point of the curve. Now, I'm not looking. You tell me whether we move the chalk up or down, right or left, until we get to the leftmost point. I see you milding it. You said left, right? Okay, just so I'm sure I can read your lips. Yeah, okay, I'm going to go left. Tell me when to stop. Okay. You can yell. You don't have to shake your head, but I saw that. Okay, that's good. Okay, now, up or down? Up. Tell me when to stop. Looks like maybe I didn't go quite up because I thought it was pretty well. We're going to end up here, right? Okay, so you're probably instructing a defective machine here, so we didn't exactly land on the point, but it's probably the machine's fault. Okay, so there's our leftmost point. And the y-axis has to go through that point, right? So where I'm going, okay, here. Not sure where the x-axis goes, but I know where the y-axis is. That's what I've got to do. Okay? Okay, well, that wasn't too bad. Anybody traumatized? Okay. Don't see any evidence anybody's having too much trouble with this. Okay. And then an x-axis, it passes a little ways below the vertex. Okay? Well, by a little ways, I mean not too far below, but definitely below. So let's just do this. There's our x, there's our y. And now we're going to label the axis so that the y-intercept is 0A. So in my case, A is, let's see, what's my first name? Yeah, 5. Okay. So here's 5. And the x-coordinate of the vertex is B, which in my case would be 4. So this is the point. Yeah, that's the vertex. There's the. Maybe we label that x equals 4 just so we understand. That's the vertex, okay? And then let the graph correspond to depth of water in the cylindrical container versus time in seconds. And actually, I thought that I'd done something. I didn't give you any instructions for changing A and B, so we got a quick container. Okay? This means that in 4 seconds, water goes from depth of 5 centimeters, is it? Yep. Down to whatever this is, right? So it looks like it goes down by at least 4 centimeters in 4 seconds. Meaning it goes down an average of about 1 centimeter per second, right? Okay? So now let the interval 0 to B be subdivided into the interval 0, D, D, okay, into these intervals. And boy, I didn't give you a calculation scheme on that one. That was going to be kind of hard to do, okay? Really, you know, I thought that I told you to multiply A by 10 or something like that, and B by something else, so we could divide it. But anyhow, you're going to divide it into 3 intervals, and they won't necessarily be equal. So let's just say they're divided like this. And when I post the homework, I'll tell you what to do with the calculation scheme, so you can do it next time. Okay? Now we're officially out of time, but very quickly, all I'm asking you to do then is sketch the fundamental triangles for the 3 points that correspond to the endpoints of these intervals, which means you're going to have a point here, a point here, and a point here. And you're going to have a hypotenuse here and a hypotenuse here, hypotenuse here. You're going to have a triangle here. You're going to have a triangle here.
That's the only thing that made me like.
And you're going to have a triangle here. Right? Then you estimate rises and runs and what they mean. What does a rise of a triangle mean? And then what's y? In terms of the cylinder in the water, what's y? Okay, well, x is time in seconds. Y is depth in centimeters, and I should have left myself more room to label it. But hey, y is your depth in centimeters, right? So your rise is going to be your change in depth. And if you're going in this direction, your rise is going to be negative. If your arrows on these things, you got to put your arrows on the hypotenuse and on the sides. Remember, you got to do all this. All the stuff I've told you to do, you need to be doing, right? And then you interpret that. Well, the rise is change in depth. The run is change in time. So it's the change in depth divided by the change in time. Okay? Which is the average rate with depth changes with respect to time. And you want to use all those words. Okay? You want to review the words that I've used in analyzing these things. I don't see the words with respect to very often. I don't see the vocabulary that I've been using, and it's important. Now, you all do pretty good with an intuitive interpretation of these things, but you're not being rigorous enough in using the words and phrases that you would see if you were reviewing at least the class notes videos. Okay? You don't have time to write it all down. Go back and look at it. Get the vocabulary, because I'm not going to give you full credit unless you're using the vocabulary. You probably won't penalize it real heavily, but heavily enough that it could affect your grade, okay? So be sure you do that. Okay.